Welcome to Lesson 3. Here we'll look at the different types of research as well as their roles within the evidence hierarchy. Here we've got the research continuum. So starting off at the far left there, we've got descriptive research, which encompasses case studies, survey research, historical research. Of relevance to nutritional coaching, some of the most interesting research has been done on case studies of physique competitors. And as we move towards the right here, right in the middle, we've got observational research. So under the umbrella of observational research, we've got cohort studies, case control studies, cross-sectional studies, and maybe memorably, we've got epidemiology. So epidemiology makes headlines because it's able to tug at the emotional cords and heartstrings with headlines like X food linked to heart disease, or X food raises the risk for diabetes, or X beverage is linked to cancer. So observational studies, observational literature encompasses nutritional epidemiology, and that's where all of the juicy headlines fall. So we'll get back to that. Now, all the way to the right here, we have experimental research, which includes randomized controlled trials. The main difference between observational research and experimental research is that there is some sort of intervention that goes on with experimental research, and the variables are tightly controlled. So with observational research, the name is sort of self-implicating its nature, that we're not necessarily putting our hands into the process and intervening. Now, observational literature and experimental literature, those types of studies have their strengths and limitations, which we'll talk about when we talk about the hierarchy of evidence. But it's important to note that we need all of these types of research. So they're all important for forming our foundation of knowledge and our ongoing discovery of the evolution of this knowledge, so we can continue to find out, continue to discover, continue to learn the nature of reality. Now, down at the bottom, we have summational research. So there's going to be a repetition, a multitude, a crushing volume of studies that get pumped out every day, all kinds of research. So what we have to do at various points in the journey is take a look at the body of studies that we have and try to synthesize what we've learned from the findings. And that is the goal of summational research. It's to kind of take a bird's eye view of the pile of studies and make heads or tails out of it, with ultimately the hope of gleaning some practical recommendations that hopefully can improve lives and help people reach their goals. So narrative reviews are a little bit more free form and organic type of article where you discuss a given topic and you can even editorialize over it. And there's a lot of interpretation. There's a lot of critique of the literature, and there is the presentation of practical applications. So narrative reviews are, I guess you could say, they're the loosest form of summational research, but they can also be the deepest form and sometimes the most useful form. Systematic reviews typically follow a standardized format for search strategy, as well as quality ranking and reporting. And so systematic reviews are much more narrow in scope and much more standardized in their approach to a given research question. So their strength is in how systematized they are, how organized they are, but their limitation is in how narrow the scope is and how little room there is for critique, interpretation, and nuance and practical application. And the same can be said about meta-analyses. Usually, there is a systematic review that is associated with a given meta-analysis. And so you can criticize narrative reviews, systematic reviews, and meta-analyses. There are ways to pick these things apart. And we may get to more of that on the next slide, but this is the research continuum. And it's good to have an idea how research is organized and what its various roles are. So next we have the hierarchy of evidence. There is no official hierarchy of evidence. You may have seen many versions of the hierarchy of evidence as it pertains to the types of research available. So this is my version of the hierarchy of evidence, and the weakest forms of evidence go all the way up to the strongest forms of evidence, and it's basically surrounded over with this light blue colored border that contains position stands or scientific consensus statements of the major organizations and narrative reviews by researchers with prolifically done original investigations on the topic. So systematic reviews and meta-analyses, while they are usually at the top of the evidence hierarchy in most versions of this, they shouldn't be seen as gospel, and I'll talk about why. But let's first start with the very bottom of the pyramid, the weakest form of evidence, anecdotes and non-peer-reviewed media. This is in reference to essentially gossip through the grapevine, hearsay, opinions of unqualified individuals, and even opinions of semi-qualified individuals, but it hasn't been peer-reviewed. We'll talk about that in a sec. So peer review is a very important process. Things like YouTube videos, blog articles, random tabloid style articles in print and online, they have not been peer reviewed. Peer reviewers are usually handpicked for their expertise on a given topic, and their expertise is usually determined by a rich history of having done a substantial amount of research, and usually primary research, published in the peer-reviewed literature on a given topic. So peer reviewers are, or at least should be, experts on the given topic. So anecdotes and blog entries, those types of things, opinions on the internet, on social media, none of that stuff is peer reviewed. And so it is the weakest form of evidence. Now, if we go a level up, now we're looking at peer reviewed research. So the next level up is observational studies. The reason why observational studies are below randomized controlled trials is because true experimental research, like randomized controlled trials, that's the only type of research that can reliably establish cause and effect relationships between variables. In contrast, observational studies typically can draw correlations or associations. And there is an argument amongst academics about the ability to draw causal inference from observational studies. But suffice it to say, for the most part, observational research, and that includes epidemiology, that type of research is causation challenged. There's something called the Bradford Hill criteria for causality. And if observational research fulfills all of those criteria, then one can build a case that, hey, we've found a cause and effect relationship in this set of observational data. An example would be smoking cigarettes and getting lung cancer. So even though that's not based on randomized controlled trials, because number one, there'd be ethical challenges to it. And number two, there would be logistical challenges to it. Just the nature of following large populations over years and decades is usually not feasible with randomized controlled trials. You have to rely on observational data for those type of investigations. So therefore, observational studies can, in some cases, demonstrate causation, but it's very difficult for that to be established. Okay, so therefore, randomized controlled trials sit a little bit higher than them on the evidence hierarchy because randomized controlled trials can determine cause and effect. Now, this squiggly line, I made it squiggly because there's not this hard straight line that should be viewed between observational studies and randomized controlled trials. And that's because both types of research have their strengths and limitations, but both types of research are necessary for us to build a high degree of confidence in what we think we know about how certain agents result in certain events or phenomena or effects. So, randomized controlled trials, although they're able to establish cause and effect, and although we can control the variables very tightly to clearly see the causal arrow, well, they are limited in that they're subject to challenges to what's called external validity. External validity is another word for real world relevance or practical relevance, clinical relevance. So, external validity is how relevant is this study design and its results to what's going on in the real world? That is external validity. So, even though randomized controlled trials can be very tightly controlled and have a lot of internal validity where the controls are the control measures are very well executed, it can still lack real world relevance because, for example, maybe the actual population or the participants of the study were not relevant to your goals or interests. Maybe the doses of the experimental treatment used in the study was irrelevant to your goals and purposes. Maybe it was just way underdosed or way overdosed. Maybe the diets used lacked relevance to your personal interests. So there are limits to randomized controlled trials and their applicability to the real world. And that is one of the big issues with randomized controlled trials is their degree of external validity, and also they're challenged by basic things like the small number of participants that's typical with randomized controlled trials. They're also challenged by the short durations that they're able to run. Most randomized controlled trials in the nutrition and exercise world are somewhere between 4 and 12 weeks. And so there always are hanging questions about the long term. So even though randomized controlled trials sit above observational research on the evidence hierarchy, we have to recognize these limitations. So at the very top, we've got systematic reviews and meta-analyses. The goal of systematic reviews and meta-analyses is to look at the research from an aerial view, look at the body of evidence, look at the pool of studies of a given topic, and see where the evidence leans, if it even leans in a particular direction. So that's the goal of systematic reviews and meta-analyses. It's like when you use a systematic review and meta-analysis to support a given position or opinion, that's kind of the opposite of cherry picking your favorite study with your favorite result and waving it around and say, this is my support. But now, just like every other type of research, we can't see systematic reviews and meta-analyses as unassailable gospel. Okay, they have strengths and they have limitations. The big limitations of sysrevs and meta-analyses are that they're only as good as the studies they contain. So, for example, if a given meta-analysis, which is a study of the studies, it's a group of studies where you pool the data together and you determine the magnitude of the effect. Okay. If that meta-analysis contains studies that have crucial flaws, then what can happen and does happen in some cases is the meta-analysis, it's a systematic review and meta-analysis, merely amplifies the flawed research. And there are different examples of that. Um, I'll give you one example of meta-analyses that you have to view with considerable caution. So whenever we're looking at the effect of low carb or ketogenic diets on weight loss, it's important to compare studies that at least equate protein between the groups, between the experimental group and the comparator group. Got to equate protein at minimum. And ideally, you would be equating protein rigorously as well as equating total calories consumed. And at that point, once you've matched those two variables, then you can compare what you're actually looking at, which are differences in the proportion of carbohydrate and fat between the diets. So there are meta-analyses out there that fail to exclude studies where protein was not equated between the groups. So it's little things like that that really kind of can challenge systematic reviews and meta-analyses, even though they're at the top of the hierarchy of evidence. So I want to draw your attention back to the light blue border and just drop a reminder that position stands, here we are, in the light blue. Position stands, also called position papers or consensus statements, these things hold a lot of weight in terms of the evidence hierarchy because they aim to represent the state of the evidence on a given topic. And there are only a small handful of major organizations that have peer-reviewed position papers. And here are the big ones. So there's the American College of Sports Medicine, the Academy of Nutrition and Dietetics, the International Society of Sports Nutrition, and the National Strength and Conditioning Association. And a great place to start if you want to know what the state of the evidence is on a given topic, like, for example, protein intake and healthy and athletic subjects. You know, you'll find that at the ISSN position stands. Now, if you want to find the state of the evidence on things like nutrition and pregnancy, you may find that with the Academy of Nutrition and Dietetics. And it goes on down the line. The American College of Sports Medicine and the NSCA, they cover the exercise side of the field. And they have position papers too, but it is a great place to start to get what's known as the scientific consensus, also known as the reliable weight of the evidence on a given topic. And that concludes lesson 3. So next up, we're going to look at navigating conflicting study results by using the PICOS framework. See you then when you're ready.